Okay, let's come back to part 2 where we're going to actually animate from our previous video. So go ahead and get your code up and ready to go with your NetBeans project open. What we're going to do is we're going to work on the sprite.js update function first. We left off at this drawImage that we're going to implement eventually here. What we're going to do is, the first thing we're going to do is we're going to make this sprite move around the screen. So we're going to be changing some values in this drawImage. So currently what we have is we have just the sprite being drawn on the screen. There's no movement, no keyboard input or anything. So what we're going to do is we're going to implement movement of the left, right, up, and down positions of this sprite. And then what we're going to do is we're going to tie that movement to the cropping of the images from the sprite to basically, essentially give you the illusion of animated movement or animation, essentially. Here we go. Let's do this in steps. Let's get the sprite moving. We already have our key states set up in here with our update function. This should actually be done in an input function, but I want to put things together to make it simple and easy for you to work with. So we're going to do an input and update all as one for this example. And what we want to do is when we look at the game.js file that I had you create as simply as possible, this is all it is. What we want is we want to do a hero.update. And what that does is it sends the key state. Now the frames per second, let's get rid of, and let's just put in 0 for now, because we're actually not using it. But that's something that you may want to use later on to basically, sometimes you need to know frames per second to do what's called a look ahead for collision detection. And you need to know the timing and how, and basically some ideas on the algorithm or to basically do better collision detection. And there's some other reasons for needing the frame rate. So that we're not going to actually use in this example. So what we're doing is the hero update, the hero draw is done. Well, we're going to be changing it, of course, but the key state is the key thing here. Yeah, that was unintended. So essentially what we're going to do is we're going to send that key state to our sprite, to our hero sprite. And what that's going to do is we're going to look at that key state like you did in your previous assignment, and we're going to tell the sprite to move based on its change of x and change of y values, which we have as 2 pixels and 2 pixels. That can be a floating point number. It's probably better as a floating point number, but again, we're just beginning. So basically we're saying when the sprite moves, move 2 pixels to the left and 2 pixels to down or up. So this is basically the velocity. Now this could be also -2 and on both for moving backwards or up. So what we'll do here is we're going to go into the sprite and we're going to draw with an x and y value now. So this x and y value we're going to use. Now remember, we have to use this .x and this .y. So what we want to do is when we push the D key, we want to set, before we begin, instead of drawing at position 100, 100, we're going to draw at position this .x and position this .y. So that is in your draw function for your sprite. Change the 100 to 100 to be located at this .x and this .y. Now that's going to be what you pass in on instantiation. So if we look at the game.js, we see that it looks like we're sending it 300 by 300 for the x and y position. So remember, the sprites values that you pass in when you create it are labeled up here, and specifically which ones they are put up here with a little bit more detail. So the x and y it looks like our sprite's going to start at position 300, 300 with a speed change of 2 pixels. So what we're going to do is we're going to say, okay, If they push the D key, which is going to be to the right, that means we want to increase the X value. So we say this dot X equals this dot X plus this dot DX. So basically we're just adding 2 pixels to it when you push down on the D key. And if you push down on the A key, you're saying this dot X is equal to this dot X minus this dot DX, because we're going to the left now, which is backwards. So remember, X decreases as you go left, X increases as you go right. So let's look at what this actually does. Okay, so I'm going to push the D key. Okay, well, oh wow, immediately we see it. We've got a problem there. That's kind of interesting, isn't it? The problem here is that we're not actually refreshing the screen. So what we got to do is as part of our update in our game is we got to actually clear the screen and make it white again. So you can clear it for any color you want, or usually what most people do is they'll actually redraw a background image in there. And that, remember, the overlay is you draw the background first and then you draw the sprite on top of that. So if you're going to draw a background, you would do it up here in the game manager. You would do it in the update function of the game, and this is where we clear the screen. Now you could draw an image here that would be the backdrop of your screen. You just do a draw image here of location 0, 0, canvas width and height. Right here, I just tell it to clear it out. So now when we run it, we have nice and clean, don't we? Okay, but the other issue is, well, we're not moving up and down, and we're not animating. So let's go ahead and get our W and S keys working. So that's going to be with the Y key. So we're going to go ahead and go back here to sprite.js, and we're going to say right here, the W key is up. So we're going to say this dot Y is equal to this dot Y. Now W is subtracted from, or Y is subtracted from as you go up. So we're going to say Y minus this dot DY. And then it's the same thing for going down, but it's plus because Y increases as you go down. Okay, so we should have movement now. Okay, we got movement now. Okay, so, well, guess what? Now it's just animation time. So what we're going to do is we got to keep track of what rows and columns in the image that we're drawing in our sprite sheet. And we do this by multiples of 65 and 66. You see that I already did that to get to the last one. I multiplied 65 by 3 and 66 by 3. So what we can do is we can call this a row and a column value. So what we need is a row and column value that dictates what particular row and column I am currently in the image, so that when I'm animating it. And you see right here that we have current row and current column. Now the current row is going to be for what image am I on in this row. It's not the row that we are currently on. That's current column. So the current column is the image that we are drawing, the current number of the current row number that or current column number that we're working on. So you might want to think of it, you're thinking it's backwards because you're just thinking as row is this way. Well, I'm talking about the current number in the row. So when I use current row, I'm talking about am I currently on the first image? Am I on the second image? Oh, actually, let me rephrase that. Am I currently on the 0th image, the first image, the second image, or the third image? Current column is, am I on the 0th column, the first column, the second column, or the third column? So current column is going to be really important because it's going to dictate whether I'm going up, down, left, or right. And current row is going to dictate what particular animation number I'm in. So what I'm going to do here is when a specific key is pressed, like to go right, we're going to set the current column to 0, 1, 2 for this guy. So 0, 1, 2. So current column will be 2, and we'll multiply 2 by 66. We'll get us our pixel number down to here for our crop. So here's where I will make a modification, and we're going to now use these variables. And if I'm going right, then that means that this dot current, now column is what column we're in. Current column, and if right is the D key. Okay, so we look at our image. Right is the D key. That's this guy right here. So that means it's going to be a current column of 0, 1, 2. So we're going to do current column times 2 here. Current column is equal to 2. Now make sure your spelling's right on this, so sometimes it's better just to copy it and paste it. Okay, so we're going to do this for all of them. All of them we have to set the current column. Okay, so let's see it here. The going up, let's see, the going up is going to be, let's go back to our, going up is current column of 3 down here. So that's going to be the W key. So let's go back to the W key, and we'll go to current column is going to be 3 here. Okay, now I didn't do A key, going left. The A key, going left, is going to be 0, 1, current column of 1. Okay. All right, now the S key, is that the only one that I haven't done? The S key is going down, and that's current column of 0. It's the very first one. Okay, so we have 0, 1, 2. Which one is 3? I messed one up. 3 is 0, 1, 2, 3. 3 is going up. It's W key. Oh, I put the 0 in the wrong spot. 3. It was the S key. Okay. So we've basically got a multiplier that goes in and allows us to multiply by the width of the original of the slide within the sheet map, or the sheet or sprite sheet. So what we're going to do is we're going to take and we're going to, when we draw this image, we're going to use that current column to tell the drawImage function to grab the correct image column out when we do our keys. So what it's going to be here is, since we are dealing with source, when we're dealing with columns, that's going to be a Y position. So we're dealing with columns, we're dealing with the Y position. So we're going to take and we're going to go to the Y position multiple, which is the second one, and we're going to say this is multiplied by this dot current column. Don't forget the this. It's important because it's part of your object. You see it kind of highlights up as you get it in. Okay, so let's test this now. Okay. Oh, that's cool. That's working, isn't it? Okay, so here's the next step is we need to get it to flow through its animation sequence. And we do this with what's called the current row. So the current row is going to be set at 0 at the very beginning. So what you got to do is, hold on, I'll be right back. I got to take a break real quick, and then we'll continue. Okay, so the current row is what actually runs you through each animation sequence. Now here's the key. The current row is going to be 0, 1, 2, or 3, but after it gets to 3, it needs to start over back at 0 again. So it continuously plays through over and over and over again whatever animation sequence we're on. So what we're going to do is we're going to add that current row multiple to our draw image, and then we're going to make it change based on the frames, so that it's done. And one thing that you also want to take into consideration eventually is your frame rate when you're dealing with some of your animations. But it's not so important because we have the callback that always makes sure that it's 60 frames a second. So we have we know what it should be usually, but often some people would want to take the frame rate in consideration with their animations. So let's go ahead and go back to the code, and what we're going to do is we're going to say, okay, this is going to be the x. It's going to be 65 times this dot current row. Okay. All right. So then what happens then is what we want is we want current row to increase, but only if our key state is being changed. So what we'll do here is we will do, within this if key state is greater than 0, something has been pressed, that's when what we'll do is we'll just go ahead and say, okay, it's time to animate an image because we got something on the keyboard. So what we'll do is we'll say this dot current row equals this dot current row plus 1. Okay. Oh, whoa, that didn't really work well. Well, obviously not, because we're not starting our current row back at 0. So we got to put an if statement here. Is if this dot current row is greater than 3, then this dot current row equals 0. And what that does is when it plays through and current row gets to values 4, 5, 6, you're not going to be able to see it. So the animation changes quick. So what it does is it's going to just keep it going from through the 4 and then start back at 0. So it goes 0, 1, 2, 3, back to 0, 1, 2, 3. Okay, so this is going to be interesting because we got to add one little addition to this. And yeah, we got an interesting little dude there that doesn't really walk or move appropriately with its speed. So you can change the X and Y value and make it move faster. So add 3 to it or 2 or something. Or what we can do is we can make current row increase more slowly than by 1. And what we can do is we can actually turn it into a floating point value. And the idea here is that what we'll do is we will count up each frame, count up until we get current row into this frame, and then draw it. So we'll count up current row of 1 times 65, and then we'll just do little slices of adding up current row until it hits a solid full number. So current row could be 1.1, 1.2, 1.3, 1.4 until, 0, and then 1. So it would be 1.1, 1.2, 1.3, 1.4, 1.5. And as soon as it hits 2, then we have it draw the next animation. So what we're going to do is we're going to add just little pieces, little slices of decimal values, so that you go through maybe 20 frames before the switch to the next animation happens. So what we're going to do is instead of current row plus 1, we're going to do current row plus 0.20. Now this is where you want to put you could put your frame rate. This is where you could this would be something where you would tailor your animation and how quick it chooses or goes between each slide based on frames per second. So you could do some kind of thing like divided by FPS or something like that here to make it so that it was more appropriate for your environment, or you can hard code it. Hard coding it is not the solution. You always want to go with some kind of ratio based on a known number that describes your environment, like frames per second, canvas width and height, so that you can go onto different size screens and different environments, and the experience will be the same. We're going to go ahead and hard code it right now. We're going to just do 0.20 and see what happens. Wow, that's really weird. Okay, so obviously what's happening is we are adding current row in increments, and it's not going with a solid cut. So what we got to do is we got to tell it to go to the floor down here. So since we're using a floating point value and our images are based on regular integers like 0, 1, 2, 3, and we're using this current row and we're going 0 and then 0.5, 0.6, 0.7, 0.8, then we get to 1, 1.2, 1.4, 1.6, 1.8, then we get to 2. So we're using the frames to help us iterate through our animation, but we have to tell it to take the number like 1.3 and make it 1. And just go, and if it goes to 1.4, go back to 1. 1.8, go back to 1. 1.9, go back to 1. 2, oh, draw this one. Then you go 2.1, go back to 2. 2.2, next frame is 2.4, next frame, 2.5, next frame, 3, oh, let's draw that one. So what you do is you take that number and you just tell it to go to the floor. So basically you take a floating point number and make it into an integer, and therefore we're using our frame rate to actually go through and deal with that animation for us. Okay, so what we do here is instead of current row, 65 times current row, we're going to use the math.floor. And that's going to make our decimal value back to an integral value until it flips over into the next number. So it'll go from like 1.2, 1.4, because we're adding 0.2. So it'll go 1.2, 1.4, 1.6, 1.8, then 2. So if you get a 1.6, it's going to floor it down back to a 1. A 1.8 is going to floor it back down to a 1. As soon as you get a 2, it takes it back to 2. When you get a 2.2, it takes it back to 2. So what it does is it's going to stop that in-between behavior of at least I thought it would. We might have some issues to fix. So let's see here. Save all. We're good on that. Okay. I got a bug to fix, so this is unanticipated. What I'm going to do is, I think the math.floor function isn't working. And this is a perfect example of where we would want to do some debugging. So what I'm going to do is I'm going to go ahead and run this. And I'm going to debug and see what's going on with this guy. And what I'm going to do here is I'm going to go to More Tools, Developer Tools. And I'm going to go to the sources. And I'm going to set a breakpoint in that draw function for our hero. So I'm going to go down here to sprite.js, open that up. Let's get this all nice and neat so we can see stuff. Okay, so then what I'm going to do is I'm going to set a breakpoint down here and see what's going on with this floor function. So I set a breakpoint there. And then what I'm going to do is I'm going to hit play. And I'm gonna go here, and what it's done is it's broken out and it's currently completing this instruction. And what I'm going to do is I'm going to select this whole thing and just see if it gives me a value. It's coming out as 0 for some reason. So what is current row? This dot current row should not be 0. It's being 0. Did I spell it right? Okay, so maybe we should just hit continue again. Current row is still 0. Okay, so I'm going to have to get this and see if this is going to be, let's do it after this. Let's do this. We'll set a breakpoint here. And then when I trip this and I know current row is going to be a specific value, I'm going to set a breakpoint here and then hit play, and then it'll go down to here and I can see what current row is actually at. So let's do an F5 over here. I'm going to restart this whole thing. Okay. Then I'm going to move to the right. I'm going to focus on this guy. Why isn't it focusing like it should? There we go. Okay. Oh, I'm using the wrong keys. Okay. Oh, duh. I'm over here. Okay. I think it's not liking me for some reason. Let's hit this guy. Oh, there we go. Okay. Current row. Okay, so current row is going to be 0.2. Okay, so if it's 0.2, I'm going to add 0.2 to it. So I'm going to do a step over. It's not greater than 3. So current row is still it's 0.4 now. So what I'm going to do is I'm going to set a breakpoint here. And I'm going to hit this resume script. And what it's going to do is it's going to stop me in the next draw function call. And that should be when current row is something other than 0. Okay, so then we go look at current row. It's 0.4. Then we multiply 65 by it. 26. I think I might be doing some of my math wrong here. Oh, I want to go out to the floor on current row before I multiply by 65. See, it really helps to get in here and start working with your mathematics and see what's going on. The debugging is so important. Okay, so I've got to take this and do the math.floor. Looks like I got to do the math.floor here. Looks like I ran out of batteries for my mouse. Yeah, unfortunately I can't even. Oh, I can pause. I think I can pause. I gotta go get batteries. I'll be right back. Let's see if I can hit pause. Okay, got a new battery in the mouse. Let's go ahead and go to the floor on that and see if that's actually going to work for us. Remember, we got to go to the floor on current row instead of the multiply. So we just take this guy out and put the times 65 here. Oh, this is hard-coded. No. We don't do 65 and 66 like this. We got to pass that in. That's got to be source X or source width and source height. Are we passing that in as the hero? Let's go back here. 65 and 66 and 65. Okay, so we got to change this to be. We'll change it after we test this and making sure it's working, so that we're not hard coded with it. So you can use different sprites and send in different data if you want when you instantiate it. It's not always the best thing to hard code. Okay. Wow. Cool. we have a working sprite. All right. Okay, so here's some things. Let's change this to this dot source width, and change this to this dot source height. So it's not hard-coded anymore. It's what we're sending into our sprite object. Okay, everything's working good. Good. All right. There's one last thing we needed to talk about, or I needed to talk about before we continue on, and that is this right here is already fairly optimized just in the manner that we do the keyboard and the key state and input. But let me give you a thought. Okay, so here's kind of the way you want to build a game. These if statements are crap. They should not be here. So what you would do is you, instead of having these if statements in here, what you could do is you can get rid of these if statements by tying your sprite map to your key state. So the keyboard does the switching for you instead of the if statements. And that's how games are really built, is why should I have an if statement when I can just tie these mathematics to a key state? So you could just get rid of the if statement, and all these mathematics here will be based on your key state. And then you can have an artist draw up your scheme that would match, your sprite map would match your mathematical scheme for how you animate your images. That's how you build games. You don't do it with if statements. You start learning how to build games with if statements, but then you learn how to get rid of if statements. And one thing to do in this manner is, why even have these if statements? We already keeping track of a key state. It's a number. Let's tie that number to these numbers and get rid of this if statement. Now, I'll give you a challenge. If you guys do that, if any of you do that and shows it to me, you immediately get a 4.0 for the class and you don't have to do anything further. Tying the key state to the graphics and getting rid of these if statements, and if you could show me that you've gotten rid of these if statements and the key values are tied directly to your animation mathematics for cropping out of your image, you could turn that in and call it a day. But other than that, thanks guys for the time. I'm sure you're having some fun. Remember, your assignment is, or has to be, with a different sprite map than the one that this is for. So make sure that you are able to complete your assignment as stated, and of course you can use everything that we did in this video. I will not be posting the code, but there is a template that is available for you to play with that we stole all this code from, that's freely available to you. Other than that, thank you. Next week I think we are on, or for the next module, I think it might be mouse stuff, or we're going to do some more, but pretty soon we're going to be getting to vectors and forces and some real fun stuff. So yeah, it's going to be even more fun. Thank you. Bye.